Hello everyone, this is session number 3 of lesson number 1. In last session, that means in session 2, we learned how to convert decimal number to binary number and binary number to decimal number. Now in this session we are going to learn how to convert next numbering system, that is our next number system, that is octal number. Now in this session we are going to convert what given decimal number to octal number. So before start to convert decimal number to octal number or octal to decimal, let's see first octal. What is octal number? Here before we learn what is octal number, but let's in short again what is octal number. Octal number is a number system. It has 8 different numbers that begins with a 0 and ends on 7. Okay, it has a base that is 8. Why? Because the size of numbers for octal, that is 8, so it has a base 8. Okay, and now let's see how to convert given decimal number to octal. Actually the conversion method or the process, it is similar to binary to decimal conversion or decimal to binary conversion. That means whatever steps we follow to convert a decimal number to binary and binary number to decimal, we have to follow the same steps to convert given decimal number to octal and octal to decimal. But there's one little change. What is that? Instead of 2, here we're going to use number 8, because the base of octal is 8. Okay, so we cannot use 2 as a base, because it is a base of binary number, and it was used in last session to convert decimal to binary. But here we are going to convert decimal number to octal. That means instead of 2, which number will be the divisor? 8 will be the divisor for given dividend. Okay, and here we have a small example to convert decimal to octal, and that is 127. Let's see how to convert a given number to octal. 127 is a dividend and 8 is a divisor. While converting given decimal number in any number system, the base of that number system will be the divisor. So here 8 is the divisor. We are going to use 8 to divide given dividend, that is 127. That means we are going to convert this number 127 to octal. Okay, and here you will get numbers, means after converting given decimal number, you will get numbers in between 0 to 7. You will not get any another number than 0 to 7. You will not get here 8 or 9. You will get a numbers in between 0 to 7. So let's see the process to convert decimal to octal. So 127 divided by 8, and one more important thing, we have to divide to that number till it does not become less than 8. That means we have to divide to given number, okay, till it does not become, or till its quotient does not become less than 8. Okay, so 127 divided by 8. After dividing to this dividend by 8 as a divisor, you will get here 15 as a quotient and 7 as a remainder. So here we got a last digit, okay, for octal. Then next, that is a quotient. Now we have to divide to quotient. Okay, the quotient is 15. It is not less than 8. Okay, so again we have to divide to this quotient by 8. So 15 divided by 8, what will be the quotient? It is 1, and remainder is 7. Here we got a last second digit for octal number. Then what is quotient is 1. It's less than what? Yet so we cannot divide it, otherwise they will get a float value, so don't divide it. Okay, keep this value as it is. And now arrange what the numbers from right to left. So first what will come, not 1 7, then 7 1, that means 177, means octal will represent 127 in 177. That means for 127 in octal there is a 177. Okay, so this is the conversion of what, decimal to octal. Okay, so here our conversion from decimal to octal. Let's see the vice versa process, that means how to convert octal to decimal. Here also we have to use the same process which we used in last session while converting what, binary to decimal. That means we are going to multiply here what, each and every digit with the base of octal by increasing what, the power index for base from right to left. Okay, and for every stage power index will increase with 1, and what will be the initial power for power index, that is 0. That means always it will begin with 0, 0 1 2 3, okay, up to n, and from where it will start, or from where that power index will begin, from right side. Okay, and that power index we have to assign, or that power we have to assign to the base, not to the number, otherwise we will get a different number. So here we have a small example, that is conversion of octal to decimal. So let's see how to convert a given octal number to decimal. Means what will be the number for 543 in decimal, that is here 355. But let's see the solution, or let's see the calculation. So first we have to arrange what, all these digits by multiplying with the base. Okay, understand? Now here we added, and also we have to assign what is power index, and it will start, or it will begin from right side. Okay, it will first begin with the 3 into 8 raised to 0 plus 4 into 8 raised to 1, then 5 into 8 raised to 2. Okay, and at the end we have to calculate what, the addition. First we have to solve the brackets, and then we have to calculate the addition, otherwise you will get what, the error in calculation. That means you will get what exact particular number, okay, but it will be wrong. Okay, so first we have to solve what, the brackets, and then we have to solve what, next step. Okay, so first you can solve any bracket. Okay, so let's begin with the right side. 3 into 8 raised to 0, 8 raised to 0 is equal to 1. There's one rule, if e raised to 0 is equal to 1, e means what, a value, any value. Okay, it can be 1000, 1 lakh, or any other value. Okay, and if its power is 0, that is equal to 1. That means what will be the answer, 1. 1 into 3, or 3 into 1 is equal to 3. Okay, here it is. Then 4 into 8 raised to 1. Now first we have to calculate what the power of 8. 8 into 1, that means 8. Okay, 8 into 1, or e into 1 is equal to that number, e. Okay, so 8 into 1 is equal to 8. That means 4 into 8 is equal to 32. 4 8s are 32. Then solve last bracket, that is 5 into 8 raised to 2. That means here we will calculate what a power of 8, which power, second power of 8. 8 into 8, 64. 64 into 5, what will be the answer, 320. Now we have to calculate what the addition, and what will be the answer, 355. That means 355, this is the decimal value for 543 octal number. Okay, I hope you all understand. So here over how to convert what, octal number to decimal, and decimal to octal. Now we are going to convert what, decimal number to hexadecimal, and hexadecimal to decimal. Okay, this process is similar to what, the previous one. That means here also we are going to divide what, the given decimal number with the base of what, the hexadecimal, to convert that given number or given decimal number into hexadecimal. That means in binary also we use same method, in octal also we use same method, here also we are going to use what, a same method, but the divisor will be different, because in while converting any numbering system we use what, a base of that number system as a divisor to divide given dividend. Okay, so here we're going to what, convert a decimal to hexadecimal. So here we have one decimal number, that is 960, which we have to convert to hexadecimal. Before convert to hexadecimal, let's see in short about hexadecimal. So what is hexadecimal? Hexadecimal is a type of what, a number system. We learn binary, decimal, okay, then octal. Now hexadecimal is a type of what, a numbering system. In decimal 10 digits are there, but in hexadecimal 16 digits are there. Okay, first 10 units and remaining 6 are digits from 10 to 50. And in this numbering system, that means in hexadecimal number system, units are used as it is from 0 to 9. And what about the digits from 10 to 15? Instead of those digits, alphabets are used. Okay, first 6 alphabets are used. What these are: A, B, C, D, E, F. Okay, till F. Later are used from alphabets. Okay, that means this numbering system is a combination of what, numbers and alphabets. Okay, that means it is alphanumeric number system. Okay, that means whenever you will get what, the remainder more than or above 9, okay, or greater than 9, so instead of that digit, you have to use what, alphabet which is assigned at that place, or which is assigned for that number. For example, when you get what, a 10 as a reminder, so instead of 10 what will come, the A. Okay, then for 11 B, then for 12 C, for 13 D, 14 E, and for 15, that is last digit of what, a hexadecimal, you will for that you had to get, or you had to use what, a F. Okay, but for first 10 digits, first 10 units, you not need to use any alphabet. Okay, so let's see how to convert given decimal to hexadecimal. We know that here the divisor will be base of hexadecimal, that is 16. We know that. Okay, and 960 is a decimal number, we have to use as a divider, we have to use as a dividend. Okay, so let's see how to calculate, or let's see the process to convert decimal to hexadecimal. 960 divided by 16, when you will divide, you will get a 0 as a remainder. Okay, and 60 as a quotient, and we have to divide to this quotient till it does not become less than 16. Okay, when it become what, less than 16, then we have to stop to divide to that quotient. Okay, now 60 is greater than what, 16. Okay, so again we have to divide to this quotient. So what is quotient? 60. And what is our remainder? What is our divisor? That is 16. 60 divided by 16, what will be the remainder? It's 12, and quotient is 3. Okay, you can see a quotient is less than what, 16, so you cannot divide to this quotient, otherwise you will get a float value. Okay, and there's no any use of float value, we have to keep that value as it is. Okay, without dividing it in decimal places. Okay, so we have what, this hexadecimal number 0, 12, 3, but 12 cannot be used as it is. It is not a unit, it is digit. Okay, and there is one alphabet. Okay, which represent the value of 12. Okay, 3 we have to use as it is, 0 we have to use as it is. What about 12? No, don't use 12 as it is. It is what, a digit. Okay, when you use as it is while converting what, a hexadecimal to decimal, you will get a different value, so don't use as it is. Okay, so use its what, a alphabet, okay, which represent the value of 10 or which represents its value, and that alphabet is a C. That means C represent value of which digit? It represent value of 12. Okay, so what will be the hexadecimal of 960? That is 3C0. 3C0. 3 C means 12. Okay, 0. Understand? So this is the process, this is the method to convert word decimal to hexadecimal. Now let's see the vice versa process. That means let's see how to convert word hexadecimal to decimal. Here also we have to use the same process, okay, which we use to convert octal to decimal and binary to decimal. That means here we have to multiply what each and every digit with the base of what hexadecimal by increasing what power index of base from right to left. Okay, and here we have to first solve brackets, and then we have to calculate the addition of what the solved brackets. Okay, and what will be the initial index for a base? That is 0. Okay, for every numbering system while converting what that numbering system to decimal, then power index will be common for all numbering system base, that is 0. Okay, so let's see, we have a small example, that is we are going to convert what C9 to decimal. We have what hexadecimal number, that is C9, and which we have to convert to decimal. Means C9 present which value in decimal, or which value is there for C9 in decimal, which we have to calculate, which we have to show, which we have to view. So let's see. So what will come first, and where we have to use what a right to left method to calculate. So first what will come? 9 into 16 raised to 0. Okay, then plus C into 16 raised to 1. Now we have to solve first bracket. Now 9 into 16 raised to 0. So what will be the value, or what will be the output, or what is the calculation of this? When he will calculate what 0th power of any particular number, that is equal to 1. That means e raised to 0 is equal to 1. E is a 16, 0 is the power, and that value is 1. That means it will return what 1 as a value. 9 into 1, that is 9. Okay, here we solve first bracket, the next C into 16 raised to 1. Now power of 16 is 1, so it will keep its value as it is. It will not make any change because it is 1, so it will keep as it is. Then 12 into 16, what will be the answer? Multiplication of 12 into 16 is 192. 192 plus 9. Now we have to calculate what the addition of what solved brackets. 192 plus 9 is equal to 201. That means C9 represent 201 decimal value. Okay, that means C9, which is equal to 201. It is value in decimal, it is value in hexadecimal. Okay, this is what a conversion of what hexadecimal to decimal. I hope you all understand. Okay, so here over this session, in next session we are going to learn what the addition, multiplication, division and subtraction of with binary. That means we are going to use what the arithmetic operators with binary numbers. That means we are going to calculate what arithmetic operations using what binary numbers. Okay, that we are going to learn in next session.